Good evening, ladies and gentlemen, and welcome to the SAIEE Load Research Chapter webinar on estimation of installed PV capacity in South Africa. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the Load Research Chapter playlist. You will find the registration link to the SAIEE TV in the chat box. Please click on it and register. It's free. And for those who've sent me numerous emails if this webinar is CPD validated, yes, it is. You will receive your certificate of attendance a few weeks after this webinar. I'd like to introduce you now to our host tonight, Mr. Marcus Dienekar, who is the chairman of the Load Research Chapter, and he is a research consultant passionate about understanding the behavior of electricity consumers. He was a technical lead of the NRS 034 domestic load research project for 19 years and led non-domestic load research in support of Eskom's geo-based load forecast tool for many years. Marcus has conducted contract load research, domestic and non-domestic, both inside and outside South Africa, with multidisciplinary teams of specialists from industry, private, and the academic sector, and has authored and co-authored over 40 international and local journals, conference papers, and articles. Through his work, Marcus has contributed to several standards and won awards for project works and publications. Over to you, Marcus.
Thank you, Minx. Good evening to everyone. I really appreciate the speakers that we have this evening. We are supported by our panelists from the Load Research Chapter, that is Lloyd Setlogo, Karen Vosloo, Mondi Soni from the PES, the Power and Energy section at SAIEE, Maputi Nkwana, and we're also joined by Ross Solomons from GeoTerraImage. Those are over and above the speakers that we have lined up for you tonight. I'd like to welcome everyone, and I will introduce our speakers, but first, please take note that there are handouts that can be found in the control panel, 2 handouts for you to have a look at. Yeah, please download those and go through them at your ease. Free handouts for everyone. Okay, so thanks. The speakers I'll introduce one at a time, and then they will present. Later on, we will go into a bit of a panel discussion for 5 to 10 minutes, and then we will hand over to surfacing questions from the audience. Please drop your questions in the question box as they occur to you, and we'll deal with them in the latter part of this webinar. So thanks, everyone. Our first speaker tonight is Wet Taljaard. He's a technical specialist at SAPFIA. Wet holds a mechanical engineering degree from University of Pretoria and a master's in mechanical with a renewable energy focus from University of Stellenbosch. He's got a design engineering experience in the commercial and industrial solar thermal and solar PV industry, and is experienced implementing, procuring, and constructing commercial and industrial solar PV projects, hybrid and off-grid, ranging from rooftops to fixed tilt ground mounts and single axis tracker projects across Southern Africa. So that's a big mouthful, but the reason Wet is here is an article which appeared in the Business Day roughly a year ago, which said industry unveils data portal to track solar power installation in South Africa. And that struck me like a bolt of lightning. I had to get Wet in to speak to us at some stage about what is in this tracking data set and how it comes around, how it came to be, and could we rely on it? So without further ado, I hand you over to Wet. Wet, the floor is yours.
Thank you very much, Marcus, and good evening, everyone. Just going to switch my camera on so everyone can can see what I look like. Really appreciate the opportunity to, alongside our partners, GeoTerraImage and Prime Thought. Just want to close the camera just to preserve the bandwidth. Okay, brilliant. Hopefully, thanks very much, Marcus. I appreciate the the opportunity presented by the South African Institute of Electrical Engineers alongside Hendri, who's done a lot of really great work at the National Transmission Company South Africa. First and foremost, I would like to just let everyone know that I do feel like a fish out of water, being a mechanical engineer, firstly in a electrical engineering dominated field, and now presenting to you at this SA Institute of Electrical Engineers. So I'll note that we've gathered. Just a quick of what we do at SAIEE and what our main role is. We are the voice of the solar PV industry in South Africa. We represent nearly 700 companies in South Africa. And our mission and vision really in a way, and it really is around these 4 strategic focus areas. And I think the most important aspect where tonight's webinar fits in is really around number 2 and number 3. So both to share information with a broader stakeholder group, cement the partnership that we have, the long-standing relationship that we have both with Eskom in general, but specifically with the system operator and the strategic grid planning unit, and then also to really build on the partnership that we're developing with SAIEE. Shot of our focus areas in the work that we do, and if there's any questions at a later stage, happy to touch on it. Just a quick overview of who we represent in the solar PV industry. We do have a tiered membership structure, and these platinum and gold sponsor members provide the most support to the association. They enable a lot of the work that we do, and we wouldn't be able to have the impact that we have without the support of these entities. So we always take them. A brief overview of our corporate members, our premium members, and then our corporate members as well. Just to give those attendees just an idea of the sort of companies that we represent in the South African solar PV space. And just a quick overview of our membership numbers. Approximately 400 of that 783 total member numbers is green companies that focus. So that is just a brief overview of what we do as an organization and who we represent. But the real meat of the conversation tonight is about the installed capacity data set, and that's why most people registered for the webinar. So let's jump straight in. The concept behind the installed capacity data set was born in 2022, and it was around conversations that we've had with stakeholders, both in the private sector and public sector, around really trying to quantify the amount of solar PV installed. Previously tried to get to that number through member surveys, through consultations with municipal distributors. Unfortunately, the accuracy and the scope of that sort of data capturing exercise really didn't meet the requirements, especially in terms of what SAIEE was planning to do with that data set, and I'll touch on that a bit later. To look at a geospatial solution, and that is really where the GeoTerraImage comes in. They have been in the geospatial data industry for over 20 years, and they are experts at extracting user satellite imagery. So we partnered with GTI really to use their expertise and their capabilities at extracting information from satellite imagery and trying to then use solar PV industry specific information and parameters to take that geospatial data and convert that to a usable solar PV install. We've been at it for just over a year. So the public access to the national level data is on the SAIEE website, and the real detailed level data is available to
folks, it appears that we're having trouble with the vet's connection. Devet, if you're online, please feel free to go ahead.
Thanks very much, Marcus, and apologies everyone for the bad connection. Hopefully this one holds. So just picking off where I left off, really the most important part is around the methodology and some of the input variables and the input parameters, and just talking through some of the process that we go through, both SAIEE and the GTI team, to get to the installed capacity data set. So just moving along. So this really fundamentally is the process that we follow. It's not a complex process. It really is around taking high resolution satellite imagery, base geospatial data, and taking that through a process. And at the end of the day, as an output, getting the system kilowatt peak rating and the installed capacity, and then really having those base data points and using that data in the different applications that we have. So just to take us through the inputs, I think first and foremost, the high resolution satellite imagery, in order for us to have a complete view of the entire country, it goes without saying that we need to have high resolution satellite imagery across the whole country. So that unfortunately is a limitation to the data set in terms of access and frequency of high resolution satellite imagery being available for the entire country. The frequency of that imagery being available for built up areas, so the large metros, is a lot higher. So it's a lot more frequent than rural areas in South Africa. So in terms of the input, those are the two most important, the two critical inputs: the high resolution satellite imagery and the base geospatial data. So what we're referring to there is the specific land parcels and all of the information connected to those specific base units in terms of land use classification, in terms of buildings on that property, on those earths, and that's really the starting point. And if I shift into the process, and I'll touch on that a little bit later, the process then really is to convert the identified system data and the gross panel area into a net panel area, and then ultimately to convert that net solar PV panel area into a installed capacity or a kilowatt peak number. And the way that we do that is through a power density factor. So in really high level terms, the GTI team and their processes are really specialized at identifying solar PV systems and calculating that gross area, that gross solar panel area on a national scale, obviously. And then where the novelty of this installed capacity data set then comes in, it's about taking solar PV industry specific information, specific knowledge, and converting that gross panel area, that is the base data, converting that gross panel area into system kilowatt peak through that power density factor. Now that power density factor is a watt per square meter factor. And the reason that is one of our main input variables is that we are able to adjust that power density factor as the data set increases and as the average power rating of these solar modules increases. We are able to adjust that power density factor, also based on the specific market segments that the panels operate in, or that the panels are in. So this is really the sort of really high level overview of the process. As I mentioned, it's not a highly complex or a highly complicated process that we follow, but where the complexity comes in is in the sheer scale of the exercise. So the GTI team, through their geospatial data, have got a database of every single property, every single erf in the country. And what they're able to do with their software is to identify solar PV systems and label them per earth and extract that gross panel area. And then with the calculation, we can then determine that kilowatt peak rating per system. And the output then really is the base unit. So every single property, every single earth in the country is then identified, whether it has a solar PV system or not. And that calculated system kilowatt peak is linked to that data set. And then that really is the power of the data set, is that it takes it down to the smallest possible unit, which is every single land parcel in the country. And then if that's your base unit, your absolute smallest unit, you can then start analyzing that data and looking at that data in many different ways. And that's really where the power of the data set comes in. From an industry perspective, yes, obviously we're really interested in what the peak power capacity is within the different market segments, but it's really about that deeper level of data, looking at trends, looking at specific municipal areas and the like, which I'll touch on at a later stage. So just on the right-hand side is just a rough sort of overview of the process. It's about using that geospatial identification, quantifying that raw geospatial data into a usable form. Just an indication of what can be done with the data set. Just if I move on, just an overview of sort of the raw data that is extracted by the GTI team. And I hope I'm not giving state secrets away here, Ross, but this is really for every single earth in the country. You've got a really long list of data fields per earth, and that's really where you can start to identify what you're looking for in that data set. So the most important one here is, does the earth have solar panels, yes or no? And then based on that, the calculations will take place, and then you can start summing and start looking at specific areas. On the right-hand side, this is an exercise that we did for SALGA, the South African Local Government Association, for their status of SSEG report. So here we're looking at the top 10 metros in the country, and we're breaking down the total installed capacity per market segment. And what we can also do is we can look at the number of installations per municipality, per market segment. And that is really the sort of data that the likes of SALGA, the likes of municipal distributors, Eskom distribution, that's the sort of data that they're interested in. And that's the sort of data that we can extract from the raw data set, because the base unit is really that small data point per stand in the country. So just taking you through some data verification and some data accuracy stats that we have. What is really important to understand is that there is confidence levels and uncertainty at basically two steps of the process. Firstly, it's in the accuracy and the confidence levels of the system identification. And that is where GTI comes in, and their expertise really shines through, that they are experts at using their geospatial data and their systems to accurately identify systems. So just to highlight, there is from a geospatial perspective, it is sometimes very difficult to discern between a residential solar PV system and a solar water heating system or a pool heating system. So really the GTI team had to be really creative about how they use their systems to differentiate between the two and ensure that the accuracy level is as high as possible. So that really is the first step. It's about the accuracy of the systems that are identified, and that's the first step. So when we talk to Eskom distribution, or we talk to municipal distributors, and we talk about the number of systems installed, that is where that first step is, in that identification of the number of systems. And then if we look at the second step, which is really the calculation accuracy. So that is really the first step is the extraction of the gross panel area, which once again is something that GTI is really good at. And then that conversion from the gross panel area into the net panel area. That is where the industry specific knowledge comes in, and also the feedback loops and the verification steps comes in. From a residential solar PV perspective, the relationship between the gross and the net area is really close to unity. So there's not a lot of wasted space on residential installations. As you move up the chain to commercial and industrial installations, that relationship starts to change. So in a CNI installation, you've got walkway areas, you've got exclusion zones on roofs. If it's a rooftop installation, if it's a ground mount installation, you've got table spacings between your rows. So that relationship between gross area and net area then becomes really important, and it's important to have that accuracy as high as possible. And then finally, it's the sum of the process. So it's that net area times that installed that power density factor, that PDF, and that final number, that 85 to 98%, that's the confidence interval that we have in that installed capacity number. The lower end confidence interval really is for the residential systems, where it's sometimes difficult to have a really accurate gross area or net area number, and that's predominantly due to the variation in slope of the PV panels. So it's really difficult to account for that in the gross and net area calculation. Whereas from a CNI installation or ground mount installations, that impact really is reduced. Firstly, because a lot of the commercial and industrial installations have sort of standard inclinations that can be built in, and the ground mount systems also have fairly standard inclinations that can be factored in. One point that I didn't mention there is on the utility scale, where we're claiming 100% accuracy. That is mainly because the public procurement scheme and the large private sector projects were manually verified, and they were manually added. So we really high confidence levels in those large utility scale projects. So just then the last point is around the categorization. So we've done a installed capacity based categorization in terms of the SAIEE market segment. And then the land use category, that's based on the census data. So sometimes if you sum up those numbers, there can be some uncertainty, but that's based on the underlying assumption of the land use category from a census perspective. Maybe since the census data, that specific application or the specific building on that land parcel, the primary use of that building has changed. So that might influence some of the confidence levels there. And on the SAIEE market segment, you might have a really small commercial and industrial installation that's under 30 kilowatts, or you might have a really large residential installation that's over 30 kilowatts, and that might skew the numbers slightly. So that's really from a process and a confidence interval perspective. That's just an overview there. And just to take you through some of the highlights. So this is a overview of the installed capacity per SAIEE market segment at the end of Q1 2023. Unfortunately, that is the latest update that we have. That's based on, or at least due to a bunch of factors. But this is the latest data release that we have. We hope to have updated figures released early next year. So just to take you through some of the insights that we've seen, the number of installations is a really key number that we use in our operations, and Gauteng leading the way there. I don't think there's any surprise, and we don't foresee that relationship to change with the updated data being released early next year. What is also really interesting is to understand the percentage of systems being residential. That's from the number of systems, not necessarily the capacity. And then another interesting insight is to look at some of the average residential system sizes. So interestingly enough, eThekwini and KZN tend to have larger average systems. And then in the Western Cape, it's a 5.8 kilowatt peak system. That's the general for the Western Cape. So just some interesting numbers that we've seen. And just on the right-hand side, that is a screen grab of the publicly available data portal on the SAIEE website. The idea is that we do update those numbers as the data set is updated. And it really gives an indication of the market segmentation nationally. So this is a national view of the market. This includes both private sector and public sector procurement. Just another application of the data really is to look at, from a municipal perspective, the number of systems are identified per Munich, and then also looking at the municipality residential breakdown. And then, once again, we've got some other residential average system sizes. Interestingly enough, the city at this point in time, so Q1 2023, the city of Tshwane was the Munich with the highest number of residential solar PV systems. So that's really interesting, and this is sort of data that we can then extract from the data set and use in our operations. Another interesting point is to look at the SSEG breakdown. So those systems 1 megawatt and smaller. From a provincial sector, Gauteng leading the way. It's the most industrialized, and then the Western Cape following suit. What is interesting is to see the residential, commercial, and industrial split. This is from a capacity perspective. Obviously, if you look at it from a number of installations perspective, the graph would look slightly different. So that's just the broad overview of the sort of data that we can extract. And just quickly touching on the impact of the installed capacity data set, how we use it in our day-to-day operations, and sort of the real work that we do with this data set. This is an application of the data to look at a solar PV penetration in a specific area. This is an exercise done by the GTI team looking at a specific industrial park where you can identify the amount of solar PV installed. You can compare that to the building land use classification. You can compare that to the total amount of roof area, and then look at a solar PV penetration rate. So this is important from a new business development perspective, from a total addressable market scoping perspective, and it really does give entities data that they can use in their day-to-day operations. A second application is to inform municipal distributors and distribution system operators about the potential impact of embedded generation on their networks. So in terms of the spatial distribution of the embedded generators, but also the total capacity, and really speaking to all of those points on the left-hand side there around power quality impact, the grid interactive nature of the generators, and really giving distribution system operators an overview of what to expect on their network and how they can plan for that embedded generation on their networks. And then another exercise that we did last year was to try and estimate the amount of battery energy storage installed from a residential perspective in Gauteng, the Western Cape, and KZN. This is unfortunately one of the limitations of the satellite data set, is that you can really only see what's on the roof. So if panels are visible to satellite imagery, we can pick them up and we can quantify that. Unfortunately, we can't see what the battery energy storage capacity is, whether that's in the garage or in a battery container or in a battery room. That's unfortunately one data point that we don't have. But what we can do is we can use the installed capacity data set as a starting point for calculations moving forward. So this is an exercise that we did, taking the kilowatt hour battery energy storage ratio to the solar PV installed capacity, and doing a few calculations to try and estimate the amount of best installed in those provinces. So this is just an idea of the sort of the sort of exercises that can be undertaken now that you have at least one data point that you've got high confidence in as a starting point to these sorts of investigations. And then lastly, really is more on the policy side and the advocacy and lobbying, the work that we do at SAIEE. This data set has really enabled our organization to engage public sector and private sector entities with fact-based data to try and enable those entities to make better informed decisions, specifically around the integrated resource plan and the South African Renewable Energy Master Plan. So what we're able to do with this data set is to map the historical solar PV installations per land use classification, per neighborhood lifestyle index, and per municipal boundary, and really go into detail to stress test the SSEG and distributed energy resource assumptions in that IRP capacity planning model. And it really gives a solid starting point for these types of conversations that have an impact on the broader solar PV industry and the renewable energy industry. And the same with the South African Renewable Energy Master Plan. Really, the data enables us to have those conversations around what the historical demand is and what the potential demand is, the potential local demand for solar PV products across the value chain. And then finally, the SALGA status of SSEG report. So this data set really has been crucial to the work that we do in trying to build and grow the solar PV industry in a sustainable way. And yeah, we are really hoping to have an update pretty soon so that we can continue with the work that we've done and that it will be able to inform our work going forward. So that is just our contact information. If anybody wants to get a hold of us, by all means. Yeah, thank you very much, and apologies for the connection issues a little bit earlier.
Wet, thank you very much from my side. It is the internet, so we have to deal with all that delivers to us. I was introduced to Hendri a couple of months ago. We were sitting in a meeting where we were asking questions about where this knowledge was coming from that was in the newspapers at intervals about the installed solar in South Africa. And we made inquiries, and the inquiries ended up at Hendri. And we are very fortunate because here we have a data scientist who actually delivers something at regular intervals that somebody really, really wants. And so Hendri is a senior consultant at the NTCSA with over 15 years of experience at National Control. He specializes in power system studies, analysis, and development and implementation of related models and techniques, focusing on electricity demand forecasting. Hendri has been involved in the renewable energy sector since the inception of first projects, focusing on the impact and generation supply requirements, including the recent increase in installed rooftop PVs. Hendri, I don't want to take anything away from your presentation. Could you please go ahead? Thank you.
Yeah, thank you very much for the introduction, for this opportunity. I've already had a chance to present at one of the previous meetings, but nevertheless, it's quite a privilege to do so again. And like you said in the introduction, I'll be looking at a different approach to what the guys from SAIEE are doing. So using an analytic approach to estimating the installed rooftop PV in South Africa. Right. So South Africa, we are very blessed with sunny weather. Quite a lot of the days, and even for some of the provinces, such as the Northern Cape, we have lots and lots of potential of sunshine and corresponding PV production from that. So because of that, we've had a massive uptake in the PV installations and basically throughout the country. Now, initially, these installations were focused on a large scale, really due to it being such a significant cost. However, as time progressed, the panels started to the cost of the panels started to decrease, and also the smaller scale panels became available. So this really resulted in quite a big increase in the installation of rooftop PV. This was also accelerated by the continuous load shedding that we saw in recent history. Luckily, it's been quite a while since we saw that, but definitely it had quite a big impact on the installation of these. There's also the increasing cost of electricity, and that's ongoing. And then there's also periods where we have either municipal distribution and or even transmission network unavailability, which also has an impact on customers, which then drives them to look at alternative resources such as rooftop PV. And then also, just to mention, there was a tax incentive for the previous SARS financial year, which also resulted in increased uptake in these. So this for us really, especially in the forecasting space, being very operational, it was crucial for us to gain insight into the magnitude of these installations. So this has really led me to the analysis that I've done using the regional demand data as well as the weather forecast information, in order to understand and get a better handle on these installations. This slide is quite busy, but I'll take you through it. Really, it's the crux of what the methodology is based on. So what I use the following variables: regional demand data. This is at transmission substation level. I use cloud cover forecasts, and I use temperature forecasts. So the above values are used at noon every day, and I do that over a rolling 3-month period. The reason for that is the maximum generation that we see from rooftop PVs is generally during the noon on cloudless days. Very important to note that. Then I do an aggregation, do this at a provincial level for all of these variables. So following that, I do a comparison on similar days of the week. So in other words, Mondays are compared against Mondays, Tuesdays against Tuesdays, Wednesdays, etc., up to Saturdays, and Sundays against Sundays. It's very important because every single day has got its own behavior and its own pattern. As you can expect, the demand is quite higher during the week, the demand for electricity, and much less so during your weekends. So every day has got its own demand profile and its own demand behavior, and that's why it's so important to compare similar days. And then corresponding to those similar days, I also look at days when there's a significant change in cloud cover from one day to a similar day. So I also wrote it there. Example would be if a particular day is sunny, and the next week, the similar day type, it's a very cloudy day. Then I do a comparison on those days to see what is the impact on the demand because of that cloudy weather. So converse to that, if I compare 2 days and it's got similar cloud cover levels. So in other words, this week Tuesday is sunny, next week Tuesday again it's sunny. Then I exclude that from my analysis, because obviously any demand behavior changes is not due to cloud cover, but rather due to other factors. Also look at temperature, it's very important. Temperature is a very big driver of demand. So if I did not include temperature as one of the variables I consider, it means that I could proportion certain demand behaviors to cloud cover, but it's really based on when there's a significant change in weather. So in other words, if it's a very cold day, then the demand is very high, as opposed to when it's warmer, then it tends to be lower. So that would be the driver for that demand behavior, not the cloud cover. So I also look at temperature to make sure that there's not any significant changes between temperature for comparative days. And then if it's not, then I would use it as part of the analysis. Otherwise, I would exclude it. I also do a range of other logical checks and parameters to remove any outliers. This is things like if a certain day is a public holiday. Public holidays are very low, as you can expect, so it would be a significant different demand as opposed to a normal working day. This is just one of the examples, but in that case as well, it's excluded from the analysis because the change in demand is not related to necessarily to the weather, but rather to what is happening during that period. So also mentioning it there, the battery storage is, I always get this question, so it's already inherently included or inherently catered for in the demand. In other words, the way that battery storage are used is a kind of a similar way from day to day. So for a similar system, you would use the sun to charge your system, and then as soon as you start running out of sun, either you would use the batteries or you would keep it for backup or whatever the case may be. But that change in how you draw demand from the system is already inherently included. In other words, it's already catered for in the analysis. So that's quite an important point. Okay, so after I filter out all the appropriate data, I then look at what is the average demand change due to cloud cover change. So I use, like I mentioned, a 3-month period. So all of the similar days throughout that 3-month period, when the conditions in terms of temperature is the same, there's no other anomalies that is leading to the change of demand, apart from a massive change in cloud cover from one day to a similar day the next week or the previous week. When I've got days like that, then I go and determine what is the change in the demand as a result of the cloud cover. Since, like I said, all the other factors has already been catered for or removed, then that change in demand is then attributed to the change in cloud cover. So because of it being attributed to cloud cover, it really means that that demand change is directly attributed to the rooftop PVs. Now, the contracted renewable IPPs, independent power producers, have already been catered for through their metering. So in other words, they've already been considered as part of the demand portion or the demand that's applied. So the resultant change is purely attributed to the rooftop PV portion. And then just a point I want to mention is I do use a ratio between your maximum generation and your installed capacity in order to determine what is the actual installed capacity of the rooftop PVs. The reason why I do that is even for the PV plants, your maximum output is never at your installed capacity level, especially at the aggregate level. And as I mentioned, I aggregate this at a provincial level. So it's important to note that if you have a certain demand change that you're seeing, it doesn't mean that that demand change is already at its maximum. The installed capacity will likely be slightly higher than that, with your aggregated maximum being slightly lower to that. So that ratio is used to determine what is the actual installed capacity that has created that change in demand. Right, so here I'm giving quite a nice example just to put all of the things that I said just now into perspective. So this is looking at Sunday, the 26th of May, and I'm comparing it against Sunday, the 2nd of June of this year. So as I mentioned, Sunday against the Sunday. And also I highlighted that I use noon of every day. So at 12 on Sunday, the 2nd of, okay, let me start with the temperatures. At 12 o'clock, there was only a 5.5 degrees difference between the 2 weeks. So for the blue line, then is the Sunday, the 26th of May, and the red line is Sunday, the 2nd of June. You can see that at 12 o'clock at noon during the day, the temperatures was very, very close. As the day progressed, they started to deviate, but I only focus on the 12 o'clock period during that day. Now you will see for Sunday, the 26th of May, so in other words, the first week, there was a little bit of cloud cover, this blue shaded area here, but very little for the rest of the day, which really resulted in the continued high temperatures that we see the rest of the day. Conversely, for the following week, Sunday, the 2nd of June, the cloud cover was also quite low during the day, but then it picked up quite significantly towards the afternoon. Now you can see, so in other words, at 12 o'clock, the change in temperature was very little. However, the change in cloud cover from week to week was 73% deviation, just for 1 week to the next. Now, if we look at, and this was just an example for Gauteng, if we look at the regional demand for Gauteng for those 2 weeks, so the green area is Sunday, the 26th of May, the lower one, and the gray line then is the following week, Sunday, the 2nd of June. Now you can see the big difference between the demand from 1 week to the week, 1,184 megawatts. Now, as I mentioned, I do consider temperature, but at that time interval, at 12 o'clock, there was very little change in the temperature because the clouds was only starting to get darker by that time. So it means that that massive pickup that we're seeing at that portion, the change in demand of almost 1,200 megawatts, is then associated to the rooftop PV. So in other words, what's happening in Gauteng as the cloud cover is picking up, the production from the rooftop PVs are dropping, which means that they're actually extracting more energy from the grid, which ultimately the larger Eskom needs to supply. So that demand deviation then, like I mentioned, is your portion that's attributed to the rooftop PVs. Now, this is just one example of one province. This is done for all the 3 months, for all the different days, and also for all the different provinces in order to get this aggregated vision. view that we're seeing here. Now, this is showing what is the estimated figure since the time that I started doing this, which was around about the middle of 2022. I know it's a very busy table, but I like to include it because it kind of shows the progression of how the installed capacity has increased over time. So you can see at the time that I started this, July 2022, this is for all the different provinces. And then at the total, it was sitting close to 2,300 megawatts. Now, as we move across to time, this is now showing the most recent estimation, which is showing that in October 2024, the installed capacity for the rooftop PVs was sitting at 6,165. So it has really been a massive increase in the installation across the provinces for the rooftop PVs. So I just want to mention that although I keep on calling it rooftop PV, just because that is mainly what it is, it actually includes all behind the meter PV production. So in other words, also ground mounted PV, as well as other PV installations that there might be, which we do not have metering of. So yeah, also what I want to mention is even though there are some months where you could see that there's quite a big increase in the estimation of your installed capacity, it's purely periods when there's a high volatility in your cloud cover. So in other words, if there's a rolling 3-month period where there were many days where 1 week was sunny, the next week was cloudy, next week was sunny, etc., then it gives you ample opportunity to see exactly what the demand impact is because of that change in cloud cover. However, if there's periods where there's quite stable weather, this is mainly focusing on your winter months, then it's very difficult to pick up any type of changes because there was not any really significant change in terms of your cloud cover. And I also want to mention that this data is actually published publicly, and they can be found on the system status report on the NTCSA website. Now, those reports are updated on a weekly basis, but these figures for this table is updated on a rolling monthly period. So for each month, I do a new estimation to see where we are tracking. This has a huge benefit for us because of its operational use. So I've compared my results against other entities because SAIEE is also presenting. I'm not really sure if I should go into too much great detail into this, but what I'd like to mention just in the previous meeting is at the time that they released their previous results, that was for Q1 in 2023, they were showing that total of 5,659 megawatt power, megawatt peak actually, for that period. But that included the contracted IPPs. So if I look at the amount of contracted IPPs that we had during that time, it means that the results indicated just for rooftop only 3,297 megawatts. And at that time, my analysis was indicating 3,243 megawatts, which means that even though we're using completely different approaches and completely different techniques, our results indicated quite similar, which really puts credit to what we are doing. And it also, gives you that confidence that you can actually believe the results. And then also to the right hand of that slide, I'm looking at what's happening with the NERSA registration. So only facilities with a capacity of 1,000 kilowatt or larger are required to register, or alternatively, if they have an intent on wheeling through our network, which means that a lot of the smaller installations are not included, and quite a large number of these is really focused on your residential side. And also, when projects are registered, they still need to be built. So they've only been registered, it doesn't mean that they're operational yet. So even if you look at the figures that I did, this was for the 6th of September, they were indicating 5,564 megawatts of installed PV. I would say that a lot of these plants have not been built yet, at least for the last 12 months. But if I say that only the projects that have been registered in 2024 are not operational, it is quite a bit lower to what my analysis is indicating. But that is to be expected because, like I mentioned, this is only looking at your registered project. However, I'm mentioning this because it does carry a lot of benefit because it actually shows you the amount of the installations that are coming up. And that really creates a huge benefit in terms of your forward-looking window. Okay. I think I'm still relatively within time. I just want to quickly touch on this subject of forecasting the rooftop PVs. So for us, especially in the operational environment, and for me specifically focusing on electricity demand forecasting, knowing the installed capacity was really just the starting point. We want to know what the production is going to be. How is it going to change over time? What do we expect in the next few days? How do we need to cater for that? So we need to be able to know how much of our generation is required from dispatchable resources. And this is specifically on cloudy days. So the reason why I'm mentioning that is, and I said it in a previous example as well, as soon as we have cloudy weather, it means that we're losing that production from the rooftop PVs. And then we need to supply that extra energy because the demand is still the demand. So it's very important for us to know exactly what's going to happen with the production so that we can cater accordingly. So what I've done is, the first step to do this is to look at what is the relationship between your weather and your PV production. So now for PV, that's specifically looking at your solar radiation and temperature. I'm using solar radiation for the forecast because even on cloudy weather, it is still possible for a lot of radiation to give you a lot of PV production. Not as much as when it's a cloudless sunny day, but there's still radiation even on cloudy conditions. So it's very important to look at your solar radiation and also then looking at the temperature. So this relationship I do using the contracted renewable IPP PV plants, since we already have their metering and all of their information is operationally accessible. This relationship then is called a facility power curve, or an FPC, and it's really a matrix that indicates what is the different outputs that we can expect at different weather conditions. And it's using a binning methodology, and again, I'm sticking to the principle of a rolling 3-month period. So, for the purpose of rooftop PV forecasting, the relationship is determined using the output from the contracted renewable IPP plants as a percentage of the installed capacity. So, in other words, this relationship is built as under certain weather conditions, how much output are we seeing as a ratio from actual production against the installed capacity, so that that relationship can be applied to what we are seeing for the rooftop PVs. And then, like I said, using that relationship, the respective forecasted weather conditions, as well as what the estimated installed capacity as done previously, is used so that we can predict what the rooftop PV's output is going to be. I'd like to mention this point. It can be one for discussion, but I think it's important to note. So I do understand that the renewable IPPs have been installed at an optimal spacing and angle. A lot of them having tracking, whether it's single axis or dual axis. They've really built the plant to maximize the amount of energy that they can supply. Obviously, because it's about money. It's about producing the most amount of energy. So this is not necessarily the case of the rooftop PVs. A lot of the times they are actually installed at a suboptimal level, suboptimal method, and the directions and angles are sometimes at some weird things. I've even seen some installations that's angled to the south, and I mean, you see some that are going to the west and the east. So, even if you drive by a lot of the households, you will see quite some funny installations. Sometimes PV panels being flat, otherwise being at a very steep angle. However, all of this actually is quite good because it creates a benefit of a more smooth output that we're seeing from the rooftop PVs, especially at a provincial level. So even though that sometimes the installations are not really perfect, it actually creates that smoothing effect quite similarly to what you expect from your contracted IPPs. So it is actually quite a good thing. And then this is just an example of what those facility power curves are looking at. Quite a lot of the times, even looking at some of the international counterparts, a single FPC is used across all hours, which is then used to do the forecasting of what you can expect from, irrespective of whether it's rooftop PV, from any of your renewable generation. However, I've noticed that, it's quite important to look at a hour by hour case, because it can be quite different. And I'm using this as an example. So on the left-hand graph, I've used specifically only 3 temperature bands, but as you can expect, there's quite a lot. I'm just using 3 just to make it easy for illustration. and then looking at what is the solar radiation and how that compares to what is the ratio to the installed capacity. In other words, the percentage of output that you can expect at those different temperature levels. So as you would think, for lower degrees Celsius, lower temperature, your output is lower as what you expect for 30 or 35. And then also, as your radiation starts to increase, you do see that quite a big steep increase in the plant, and then how it flattens out at higher radiation levels. So this is the principle of how the forecasting is done. So based on a specific radiation forecast and a specific temperature, you've got what that output can be of that facility, which is then used to produce the forecast. Now, if we look at, that was an example of at noon, at 12 o'clock during the day. If we use the same temperatures at 7 o'clock in the morning, you see quite a different picture. So as your ratio, as your solar radiation increases, you still see your ratio of installed capacity, your output of your plant increasing, but at a much lower level. Now, that lower level is not due to temperature. So there are periods when at 7 o'clock in the morning is 25 degrees, and there are areas where it's at 30 degrees. Believe me, some areas are very hot. But still, the radiation, the angle of the sun is not as optimal as it is at 12 during the day. And that's why you've got lower production at the morning as what you would see at noon, even at the same temperature levels. So the angle is also quite important. And that's why I use different facility power curves for different hours of the day, and then apply that to ultimately do the forecast. So I'm cognizant of the time, but this is looking at an example for Gauteng. If we look at the weather, the black line is showing the temperature for Gauteng starting on the 13th of March. So earlier this year, going up till the 27th of March. The shaded area is looking at your cloud cover, and the blue bars here is looking at your rainfall. Now, as you can see, at the beginning of this period, there was quite a lot of days with hot weather, cloud cover towards the afternoon with a little bit of rain. And corresponding to that, for Gauteng, the rooftop PV production is quite high. Now, looking at closer, when we get to about the 23rd of March, you will see that there were a number of days where it was cloudy weather, much more rainfall, and the temperatures at a much lower level. Even though it was summer, so it wasn't cold, but definitely at a much lower level. Now, because of that, you can see that a lot of cloud cover and lower temperature, how your output of your rooftop PVs has dropped, running for about 1,200 megawatts for Gauteng, dropping to just over 800 megawatts for that period where there's a lot of cloud cover and cooler weather. So this effect of what's happening for the rooftop PVs is what we need to cater for and need to be able to predict. So for that similar period, just looking at all the provinces combined, so not just Gauteng, but all of them, the green line at the top then is showing the total with the different provinces distributed in between. So you can see starting at the 13th of March till the same period, we were running close to about 4,000 megawatt output from these plants during the middle of the day. And then you can see as we got much more cloudy weather and throughout a lot of parts of the country, and you can see how we're only running to about 3,000 megawatts. So this is a significant benefit to us. So if we are able to predict this and know that we are going to drop by 1,000 megawatts from our rooftop PVs, we are able to cater for that effect and plan accordingly to have enough generation available to cater for them. Yeah, so that is it. I know I've talked through it quite quickly, but I just wanted to give extra time to my colleagues. Thank you.
Henri, thank you very much. Your effort is much appreciated. Okay, thank you very much to both of our speakers. I'd like to just kick off with some comment, and we can have a bit of a panel discussion, and then we'll go forward to addressing the questions which the audience have put to us. Obviously, one of the big questions with regard to both of these data sets is accuracy and uncertainty, the sustainability of them, their granularity, how one can access them, and their cost. Just in comparing the different data sets that we have here and that we're very fortunate to have in South Africa, we have a data set from NTCSA, which is largely lumped in a way. It might be able to go down to sub-region. And on the other side, we have very much more granularity with the data set that is available through Sapphire, but the frequency of the repeats on that data set are at a lower end than the monthly repeats that Hendri and his team at NTC SA are producing. So I'd like to sort of open for a panel discussion now, and amongst the panelists that are in with us, Mondi, do you perhaps want to kick off with your view, what you see and the value?
Thanks, Marcus. Thanks for the invite to make comments here. My name is Mondi Soni. I'm with distribution planning, distribution technology, Eskom. So I think from my side, as someone from the distribution space, I find these two systems or platforms extremely important, and both of them for seemingly different reasons. But I just want to start with the last one that was presented now by Tibet. Great work, and we know what happens at a local level or a small area level when it comes to customers. And I think as people in the load research space will also understand this very well. Customers that are close to one another tend to have a similar behavior. So you will see this in your living standard measure layers from Stats SA. You will find that these typical customers that are earning so much, they are most likely to be close to one another, and hence we have then surpluses that are then defined by similar behavior. So now, why I'm linking this to that kind of load research environment is that when it comes to now these rooftop PVs, you have a low voltage network that is connecting these customers at a local area, which then aggregate to a smaller MV, your 3.3 or 6.6, etc., and your 11 kV. And now, just one of the pictures that was shown now by Debate there that paints the situation very, very well is that you have a likelihood that in one area, you can have a surge of these installations. And as a distribution planner, if you do not have that understanding, these installations are spread around this area and there are higher density around this area, you really get caught without really, being prepared. Firstly, we have a potential problem of voltage rise during certain times, which is where the PV is up. And also maybe Chair, Program Director, at some point in the load research, there was a presentation that was made by Yaku Albert, where he basically demonstrated how the load diversity diminishes as the adoption of rooftop solar PVs increases. So basically, in some way, leaving a high coincidence of load at a certain time, be it your days where you've got an overcast, or be it in the evening period. But the disappearance of the sun and the appearance of the sun just happens at the same time in the local area. Hence, you have the diversity, diminishing. What does that mean now? So what it means is your infrastructure locally gets overloaded at the same time more than it would normally have been if there was diversity among loads. And also you may have, as I've mentioned, those voltage swells that happen in local area. Now, data sets like these that have been presented here, they actually give you an understanding upfront to say, in these areas, I am likely to experience certain, these types of problems. And then you can start throwing limits if you need to do that. The same way that we have what we know now is GCCA, you could have similar limits that you assign at lower voltage levels, or you could also put plans in place to make sure that you don't run to those, whatever solution that seems to be good for the economy, you can evaluate and put in place. So I think, Chair, for planning of the infrastructure, for municipalities, for distributors, etc., this is extremely important. But then also, when you start to go at a larger scale, look at the aggregated level, looking at the impact at a bigger scale, which is what was also presented by Hendri. I think, when we start to look at master planning level, the bigger infrastructure, the planning of our, sub-transmission network, etc., and transmission, I think that also becomes extremely, extremely important in ensuring that you have plans in place, you know exactly what to expect, and you have solutions. So lastly, Chair, in terms of my presentation here or my comments, is that we just, I think all of these, we've been saying now for years that the way we do planning needs to change. We have always been doing network planning on the basis of worst case scenario. And now we have always known what that means and when the worst case exactly happens. Recently, I have found myself having to chase the worst case. In the last year, in one substation, the worst case was happening in the evening. And when I go back to that same substation, the worst case has shifted now to a different time of the day. So this now requires us to start looking at time series studies so that we can arrest these kind of problems. But a lot of data is required. And of course, all of this requires huge computing power. So, Chair, I will stop there. And I know you requested me, I don't know if you are back, you requested me to also just hand over to the next speaker. I don't know, in the panel, I see that there is Karen. In fact, the first person that I see is Elsie on the panel.
Fondy, Marcus here. I just wanted to welcome Elsie. She's from GeoTerraImage, along with Ross Solomons. So, Elsie, you're welcome to comment if you wish.
Much, Mondi. I think the 4 points that Marcus raised was in terms of looking at our data set in terms of sustainability, granularity, how to access them, and then the cost of them. So how to access them, obviously GTI is a commercial company, so we interact with clients on a commercial basis. In terms of granularity and sustainability, I'm going to let Ross answer that, and also maybe just give you an update on when we're planning to run some updates, etc. And then in terms of costs, we do have different costing models and pricing models for clients. We also try to accommodate them with the budget that is available. So it's not set in stone, and it also is dependent on which requirements the client has. You can't compare the same client that needs only, I'm going to say, a small municipality versus another client that would like information on a provincial scale. So that's in short.
Thank you, Elsie. Ross, you were mentioned in passing. Would you like to come in and fill in there?
Yes, thank you. Thank you, Marcus. Thank you, Elsie. So very interesting presentations, I must say. Hendri, very fascinated in your methodology. Extremely interesting how you bring in all those different metrics to calculate your estimates. Very, very fascinating. I'd love to, if it's possible, have a conversation with you in future about that, actually. It's very interesting to look at it compared to ours and sort of, just in terms of gauging how well we are all doing with this, with our work. I think it's extremely interesting. Just a brief word on the sustainability and the accuracy which you brought up. So I think it's very sustainable. Really, as David mentioned, the entire process, or a very large portion of the process, is related to satellite imagery. So as long as there's satellite imagery that we can acquire through various suppliers and so on, we can actually build these updates. And in terms of the accuracy as well, so we do some quality checks for the accuracy of the data. So obviously it is We do employ artificial intelligence to identify these installations. So we do lean quite heavily on artificial intelligence. There's a number of ways that you can do these kind of studies. I suppose the most raw way is actually physically going out and either, property to property, going and identifying these things, which is totally unrealistic. The other one is to manually capture these panels, which is possible, but would take you an enormous amount of time to capture them manually. And so we rely on artificial intelligence. So there is a small percentage of, where certain things might be missed or misclassified. And we find that by doing quality checks in certain areas where we actually take small portions of the country and manually map out the solar panels and then run our calculations to SAIEE's inputs as well, we are then able to compare that to our AI models. And so, as David mentioned, we get anywhere from 85 to 90% accuracy. And it's something that we are always trying to improve and always open to suggestions. So, yeah, and that's what I'd like to add in that regard, Marcus.
Thank you, Russ. That's very good. You're intimating at training and testing, and that's how the system is tuned to get your best result possible over a great amount of area.
Let's just touch on that quickly, Marcus. So that's true, and just importantly, so we do retrain these models, fairly regularly, and moving forward, we hope to train them to an even greater accuracy than that. But absolutely true. The more we train them, typically the better they get. So yeah.
Yeah, thanks. Karen, from your background on the Eskom planning side, have you got any thoughts on what you've just listened to?
Thanks, Chair. Yes, first of all, thank you very much to the speakers for very informative information shared. As a sub-transmission planner, I'd like to link to what Mondi Soni, some of his comments. As a planner, and with the uncertainty of the PV and the uncertainty of the batteries, we are still stuck with the requirement to actually plan for the maximum installed capacity that will be required when there's no sun and people don't have their batteries installed. So that's the one aspect that we still stuck with. And I'm sure new approaches are needed to be developed to deal with it. But the other thing is also, especially where PV systems are actually feeding back into the grid and you have your voltage rise issues and so on, who really pays for the grid upgrades needed? And how can one then limit your solar, rooftop solar installations to limit the impact of it? So all of those issues remain challenges that would need to be dealt with. Just a quick question to the speakers, panelists. You did mention that obviously you don't have a view of the batteries. Maybe a question to Hendri. Is there any way that one can actually estimate the battery availability by looking at your cloud cover and your evening demand? So that's just a question that I'd like Hendri to perhaps just touch on. Thank you.
Thank you, Karen. Hendri?
Yeah, thank you. Battery storage is always the logical next question that comes when we start looking at these things. So, you're laughing, but I mean, it's not a surprise that it's being asked. So first of all, the estimation is really looking at what has been installed in terms of your PV panels. So in other words, what is the impact of your panels in relation to what's happening with your demand? However, like I mentioned, is the battery storage is kind of inherently included in your demand behavior. So in other words, if somebody has got a PV system and they're running on the PV panels during the day and on batteries during the night, they will most likely carry on doing that unless something quite significantly changes. So from my side, it's very, very difficult to isolate the component of your batteries. I'm certain that using a lot of further deep dive analysis, it should be something that we can get a closer handle on, but it would require quite a significant amount of work. So at this stage, the clear answer is To know how much installed there is in terms of battery in storage, I don't have an answer to that. It is inherently part of the demands. In other words, the analysis for your installed capacity is clean, but to know how much that inherent component is very difficult to isolate.
Yeah, thank you, Hendri. Lloyd, do you have any comments from your side?
Hi, Marcus. Thank you. A big thank you to the two presenters, Wet and Hendri, for such a very important information, the presentation that they've shared with us. Just briefly, Marcus, from my side, the first point, which is a takeaway for me, is that SSEG combined with the battery energy system, we will be able to use it for the purpose of customer segmentation, particularly for DSM purposes. So for me, that is a big takeaway, particularly when the system is constrained. The second thing is that the numbers that they have shown to us, I mean, both entities are actually saying that the numbers are really accurate. So the confidence level is very high there, which is a good thing for us for the purpose of designing and also planning the LV networks. I have a question, Marcus, if maybe the two presenters can maybe answer this. Normally when we look at high-income households, the thinking is that the high-income households or the higher LSMs will have access to appliances and therefore their ADMD will be higher. But then because of PV, they have the means to be able to install PV. And then we realized that actually their ADMD is not that high. When you look at customers who are on the same feeder, let's say the feeder is 50% installed in terms of PV. How are you going to determine for future purposes that the remaining 50%, when you look at this field, the customers who are in that particular neighborhood, that these ones, the ones who have not yet installed PV.
Lloyd, we're going to have to cut you. We've got a network disturbance again.
Chair, maybe if I can just quickly come in. I think, yes, I think probably the core of the question is you are now sitting at 60% penetration in this specific area. How do you forecast the remainder of, to say you are likely to reach, or the take-up of those installations? So the question is, yes, you can work out what is there, but how do you now start looking at what can possibly happen going to the future? And perhaps are there any sort of confidence or scenarios that can be thrown around that to say the future is likely to look like this? Is that something that we are looking at? And that's the question to the colleagues. I hope that's what Lloyd wanted to ask, because that's what I heard. Maybe it's what I wanted to ask. Sorry. Thanks.
Yes. Thank you, Mondi. It does seem like there needs to be some sort of an econometric model. Wet is saying that he has a response for that. Wet, you're welcome to come in.
Thanks very much, Marcus. Yeah, I think from a data set perspective, this is where the indexed nature of this data set really comes to play, where the GTI team are able to create specific indexes based on parameters, like Lloyd mentioned, whether it be neighborhood lifestyle index, whether it be proximity to shopping centers, whatever view you want to take, whatever lens you want to put on the data sets, you can segment the data, and that can then be used in an index way or in a predictive way. That data set can then be used for this specific application. And we've seen where the presence of solar PV systems can be used in the inverse to predict the income levels of households where perhaps the neighborhood lifestyle index confidence levels aren't necessarily that high. So the solar PV inverse is now, or the solar PV data is now being used as an inverse to the neighborhood lifestyle and the household spending index or indices. So that's a really interesting use case. Just one other point to add, Marcus, is Lloyd mentioned around the high income households generally having sort of a higher ADMD or higher power consumption. this is something that from our perspective that we are seeing that is starting to change, where high income households tend to have access to higher efficiency equipment and sort of high efficiency appliances. So even though they might have sort of a larger footprint in terms of the amount of appliances they have, actually the amount of energy or the energy requirement doesn't necessarily scale. And this is something that we've seen in other markets as well. So that's just one point that I wanted to add, just for a little bit of extra info there.
Yes, thank you, David. Much appreciated. For me, the interesting part is that the interplay between the work that Henry's tabling and the spatial data set that SAIEE is publishing. I think there is potential there for interaction between the two, but let me not hog the floor. I'd like to get to the questions, and I'll start from most recent first, if I may. We've got Uderile saying, thank you for the great presentation to both panelists. Does the model also take into consideration shading from obstacles, especially for CNI and residential? Is that the reason for the low confidence? Low confidence as in, I guess, the higher uncertainty. That would fall to you, David.
Thanks, Uderile, for that question. I think where the lower confidence level really sits is on the residential installations, and that is sometimes based on maybe the orientation of the panels being at a really steep inclination, or being obstructed by chimneys or trees or whatever, that makes extracting that base gross panel area either tricky or it decreases the confidence level. So then you sort of have to estimate what that panel area looks like. Whereas for commercial and industrial applications and the larger CNI projects, you don't necessarily have that same obstruction. So you can extract that gross panel area with a much higher level of confidence. And that's why we see the end product of the process, the installed capacity number, having lower confidence levels for the smaller installations in the residential market segment.
Yeah, thank you. That makes perfect sense. I have the further two questions from the bottom. I've got Rochelle talking about, have we considered data from SAD and DTIC for those who import equipment and users who have raw claimed tax rebates? I would guess that speaks to another form of assessment of panel equipment to be used for scaling or calibration. Is that something that yourselves have looked into, David and Hendri?
Thanks, Marcus. I'll quickly answer it from a SAIEE perspective. The import data that's a key data set that we look at on a quarterly basis. Unfortunately, when we want to start attributing or segmenting that between different market segments, it becomes really tricky, and that is primarily based on the data that we get from SARS. The HS code for a solar panel that's used in a residential installation is exactly the same as utility scale. So from that perspective, it's really difficult to know where those panels are going. And also, it's really difficult to trace whether those panels are installed in South Africa or whether they passed into neighboring countries. So we definitely take that data on board. We do use it for other applications around sort of market sizing and market sort of momentum and demand, but not for this specific application around estimating the installed capacity. We hope to get really in-depth data from SARS around the tax rebate for residential solar installations, hopefully early next year, and then the corresponding tax rebate as when that ends for businesses at the end of this current financial year. We hope to extract some of that data from SARS as well, and we'll make that data available as much as we can, obviously, but we're really looking forward to getting our hands on that data set as well.
Yeah, thank you, David. Henry, anything from your side?
Yeah, thanks. My response is quite similar, not exactly the same. Also, it doesn't form part of the analysis the way that I'm doing it. Since I'm looking at it from a top-down perspective. So we're actually getting into account level detail. However, it is something that is looked at to make sure that there's at least alignment with what's being done, but it's not directly included as part of the analysis.
Okay, thank you. Denny, we've got another question.
Sorry, Chair.
Go ahead.
So I think this probably was mentioned. My ears decided not to listen, but I'm interested to know how easy is it. I understand the data from the from NTCSA, how the access there, but how easy is it to access this sort of portal, if we can call it that? Because I think it's a portal at this point, David. How easy is it to access it? Is it something that is available at a cost, or is it open source, or you request access? Thanks.
So just to quickly jump in there, we have aggregated data publicly available on the SAIEE website. So looking from a national perspective, that data is available publicly. So on the SAIEE website, there is a link to it. And then for SAIEE members, we've got one level deeper than that. So SAIEE members can look at it from a provincial view, both in terms of the market segments and in terms of the quarterly sort of growth. Any deeper level of data, more granular, would have to go through the GTI route in terms of procuring that data. And Ross and Elsie, please jump in after me here just to give more information. But those data sets are in shape files. So you would have to have some form of interface to be able to interpret those shape files to extract the data.
At a cost, or and how much?
Can I jump in here, if you don't mind?
Yeah, please, Ross. This is not my area of expertise. Please take it away.
Yeah. Okay. So as David mentions, it's very accessible through us at the more detailed data sets for sure. It's just a matter of contacting us, and then we'll really discuss price there. It's a very difficult thing to give a price over on a panel like this, because there's lots of things that go into it, and there's lots of different attributes that are included in the data set. But anybody who's interested can give us a call or contact us via email. Yes, as David says, it's accessible via shapefile or geodatabase feature class, but we also try and cater for people who aren't geospatially geared, I suppose, with that kind of software. So we also will build like dashboards in Excel or even Power BI, or however we can, however you're able to consume the data, we can provide it. But it is a commercial data set, so it's not open source. But at some level, as the vet says, they share certain values, which is open to the public. And then I think members also get access to another level of granularity. But the actual data sets that go into that in detail, you have to just chat to us about and get it through us.
Thank you, Ross. I have a couple of comments here. We have people in the audience that are interested in assessing the amount of battery that we have fitted in South Africa right now, through different means, and also accessing the residential meter. It's all the sort of intrusive stuff to get more information about how the customers are behaving. But I think the bottom line with all of this, and even the registration of systems, bottom line of all of this is no, we don't really have a direct take on anything other than the panel surface area and the assumptions about how much battery and other subsystems would be linked to a panel designed with that sort of area. From a standards point of view, allowing or making provision that more data comes back from these type of installations, yes, it would be useful, but those kind of requirements are not in place yet. Henry, George has asked a question here. How do you exclude the effect of wind installations that might increase during increased cloud cover and lower temperatures, especially in the Cape? Is that something you've given thought to?
Okay, so it's a pretty good question. So just to mention that all the contracted renewable IPPs has already been catered for. So in other words, all wind generators is contracts with NTCC. We have got the forecast, we have got the metering, we know exactly what's happening there. So that component is already being catered for in the demand. So the only thing that would create an uncertainty is when there's behind the meter wind turbine installations, which at this stage, as far as my knowledge, is very, very small. So for sure, it is something that's unknown. But that component is I wouldn't call it negligent, but I almost wanted to hint at that.
Okay, thank you. All of you, both presenters, should obviously be made aware that there are people in the audience this evening right now who are actively busy involved in promoting small wind installations in South Africa. So the trouble is amongst us already. There will need to be some way of tweezing the wind contribution out in future.
Can just comment on that. Then it would be quite a good thing to start focusing on next, because what happened with the rooftop PV is we kind of left it until it got to a point where it was like really a big problem. And it would be really great if we can start focusing on this so that we stay ahead of it. So thanks for that.
Yeah, if we've learned anything from the past, it's to act differently in the future.
For sure.
Thank you. Yeah, was the comment from the floor?
Yeah, so just quickly, I wanted to say maybe the two next biggest challenges that perhaps in the same space need to be looked at by those who know how, it would be those micro wind turbines. We do see them. And even the manufacturing capability here locally is starting to take up a little bit. We have done, I think, not too long ago, a market scan, and we realized that actually there is a huge potential locally going into the future. So that's one. But then also this question of batteries, I think that will also need some data guys who know how to analyze data to start looking at this thing, start taking apart the different profiles that we see, try to remove the PV component, try to remove, all the different components and see how you can have a fair estimation of the battery. And the main reason for that would be if you find, I don't know, maybe Lloyd, you can say something at some point. If you find certain customers in a specific area subscribing to a time of use tariff, and they are most likely to want to charge at night. And again, going back to that thing that similar customers or customers that are close to one another tend to behave the same way. You might now shift a problem to the midnight during the low tariff period. So I think there can be something that can be done. Obviously, I'm not the one who knows what to do. Thanks.
Yeah, thank you very much, Mondi. We should take note of that. Henri, I'd just like to draw your attention to a question from Dalen Chetty, which was probably the second substantial question we've got. Dalen wants to know, is it possible to determine battery storage capacity for installations with PV and batteries as opposed to PV only on days with extreme cloud cover by analyzing an anticipated evening peak, either stretched in time or higher in peak, when batteries are probably replenished from the grid? Okay, so he's talking about what happens. Yeah, go ahead.
Yeah, I think so. I've kind of answered this question to some extent, but I also just need to mention that specifically looking at your PV generation, you will note that it's targeted at your sunny hours. So when we look at peak and evening peak, that's already after dark. So irrespective of whether there's cloud cover or not, you won't get generation from your PV, apart from what's happening with your battery storage. But again, the battery storage will not then be in relation to what's happening with your cloud cover, but rather what's happening with how often it's being used, how tight is the system, how many days we've had of load shedding, etc., etc. So there will be other situations that impacts how that battery is used rather than the cloud cover, because ultimately it's already dark by that time irrespective of cloud cover. So looking at evening peak will be very difficult to really have any say on that energy storage.
Thanks. And this is my last question. It's an add-on from Dalen, and it really is to all of you, but both the presenters. Would you say that most installations in SA is PV with battery or PV alone from the assessments and data that you've worked with? It probably doesn't relate to you, Devet. Possibly Henry would have more insight. I think I know what the answer will be. Go ahead, Henry.
Yeah, I think it really depends on what type of business you have and what type of industry, but I think it's very likely that it's more so with battery rather than lesser, because it just makes sense. I mean, if you're going to put in the capital to put in the system, put in a system that can carry you through any type of event, especially, I mean, the convenience is there for residential, but the business sense is there when you get to commercial and industrial. You want to be able to continue with your business. So I do think that is a large component.
Yeah, I'd agree
Marcus,
with
if
you.
I can maybe just add from a SAIEE perspective. So in the residential side, it really is, 85 to 90%. It's a really high penetration of battery energy storage with those systems. And the reason we say that is we get that from our distributor members, so those who actually sell the systems, and from our installation members. The two are really closely linked. The other reason we could see it is the drop off in the amount of residential installations this year compared to last year. So there is a direct link between frequency and intensity of load shedding and the residential sort of market momentum. So that is really closely linked. And the slide that I showed about trying to estimate the amount of battery energy storage from a residential perspective really speaks to that point. And the reason we've got that one ratio of 1 to 2, 1 to 1 and 1 to 2 as the sort of bounds of that is based on some of the feedback that we're getting not only from our installation members and our distributor members, but also through the Banking Association of South Africa, their valuer teams who actually go out and assess the value of these systems. And interestingly enough, the feedback that we receive from them is that a large proportion of the systems that they actually go out and assess the value, the relationship between kilowatt peak solar on the roof and kilowatt hour battery energy storage is closer than 1 to 1. So what that would mean is you'll have a 5 kilowatt hour battery energy storage system and a 5 kilowatt peak solar PV system, which has really changed the way that we approach those conversations. In terms of the commercial and industrial space, last year, feedback that we received from our commercial banking members, the likes of ABSA, Nedbank, RMB, and the like, is that up to 85% of their commercial and industrial projects had a battery energy storage component. As opposed to this year, that number has dropped to around 35-40%. The reason is because of the CapEx intensive nature of the projects. That's the first limitation. So businesses are really thinking long and hard about should they go the additional CapEx expenditure of putting in BESS alongside the solar PV. And then the other point is what we're hearing from our members is that end users are being a lot more strategic about where they're actually installing solar and BESS or pure grid tied solar. Whereas last year it was just, put in solar batteries wherever you can. We need to keep the lights on. We need that business continuity. This year, what we're seeing is that those end users are being a lot more strategic. So in those municipalities that have tariff structures where battery energy storage makes a lot of sense, those systems are being installed. In other Munichs where it doesn't necessarily make that much sense, or perhaps the business have got some CapEx constraints, they really are going into grid-tied systems only, but with a view to installing BESS if the market conditions changes or the installation costs come down to a specific level.
Yeah, Thanks, Devette. So you're saying it's really a trade-off between business continuity as one requirement, and the other one is effectively managing cost of operations down, which is not so battery dependent. Obviously, all of that depends on the tariff regimes which we're expecting to come in. So, but that's a discussion for another day, and hopefully we'll get some tariff guys into that conversation. From my side, I think we have got very good views all around, and we've got two good presentations for the audience to think about. I'd just like to thank the members of the panel from the Load Research Chapter Exco that have sat in, and to you, to you, Hendri and Devette, and Ross for standing by for us, and Elsie. That's much appreciated. Also to the members in the audience that have given us lots of questions to think about. Dalen is one of them, and George, and Malopi, and Rochelle. Much appreciate your questions, guys. It's interactions like this that make us dig deeper than we normally would. So thanks everybody from my side. Minx, if there's anything further from you, please come in now.
Yes, thank you very much, Marcus, and the Load Research Chapter team and all our panelists. Thank you very much for a very informative webinar. I just mentioned in the chat box that perhaps we should have a follow-on webinar on this topic and rope in the SAIEE Energy Storage Chapter so we can have actually views from both sides. But yes, here we are to the end of the webinar. Thank you very much for your time for tonight, and I bid you a good evening. Goodbye.
Thanks everyone from me, and have a good evening further.